Alright, so another question. So this is a question from UNEB 1995. This was question 9.2. Now we're going to look at an example where integrating by parts is simply just a step. So we're being told to find the integral of 3 to the power root of 2x minus 1 dx. So what are we going to do in this case? So let's solve it. So the integral of this, as you can see, this number will first require us to first use U substitution. But as I've mentioned before, that U substitution can be used with any letter. But remember that we can use any letter. Now, because in this case, there's actually going to be an integration by parts later on, I'll use a different letter than U to do the substitution methods. So I'm going to let t to be equal to root of 2x minus 1. Then, as you can see, this is the same as putting that to the power a half, and then therefore dt dx shall be equal to, so if I differentiate this, I can say that I need to use chain rule. So when I differentiate this, I will have 1 over 2x minus 1 to the power a half. Then therefore we can say that dx shall be equal to 2x minus 1 to the power a half. So this is what I get. So therefore I can substitute that back right here. Remember that we had let the power to be actually equal to t. Alright, but we shall remember that t is actually equal to 2x minus 1 to the power a half. So that means we're going to replace this with a t. So that's going to be important to remember. So we'll have integral of 3 to the power t times t dt. So this is what we end up with. Now when we have it in this part like this, you can actually clearly see that now this will now require integration by parts as we continue. So you can now integrate by parts. So integrating by parts, we're going to let u to be equal to t, and we're going to let dv dx be equal to 3 to the power t. So what happens is when you differentiate u, we shall actually say that we have du dt being equal to 1, and then here to find v, remember we're going to integrate 3 to the power t, of which our v shall now be equal to 3 to the power t over ln 3. So this is going to be a knowledge that's very important. So we learned this from the video on exponential integrals of exponential and logarithmic functions. So now integrating by parts, this is the formula. So we're going to substitute in the values, and we'll have 3 to the power t times t over ln 3, because I'm multiplying the u and the v, minus the integral of, so where there is v is 3 to the power t over ln 3 times 1, of which du dt is 1 dt. Then this is what we end up having. So I can actually pull out 1 over ln 3, because that is a constant, into the integral of 3 to the power t dt. Alright, so now basically the integral of 3 to the power t shall be equal to, we shall have 3 to the power t over ln 3, and then we'll have this plus c because we've actually integrated this side. Now as you can see, when I multiply this to this, I'll have ln 3 squared, and then 3t shall be at the 3 power t shall be at the numerator. Then I can say that I can actually factorize out a 3 to the power t over ln 3, and then inside I'll be left with t minus 1 over ln 3, and then plus c. But remember, t is actually a root of 2x minus 1, so therefore this means that we'll have 3 to the power 2x minus 1 over ln 3 times bracket 2x root 2x minus 1 minus 1 over ln 3 close bracket plus c. So this is therefore our final answer, as you can see right there.